Now we're going to talk about forces, but before we do, we're going to talk about motion. Just a little bit of review on projectile motion, which is the motion of an object on which the only force acting is gravity. And the direction of the force of gravity, as you may recall, hopefully, is down. So on the Earth, gravity is always acting straight down or towards the center of the Earth. Really is the direction of gravity for objects that are on the Earth. Realistically, a projectile will also have friction or air resistance acting on it, sometimes called wind resistance or drag, but we will often ignore that for simplicity's sake in our studies with projectiles. Air resistance is always opposite to the direction of motion. So forces. We've learned a little bit about gravity and motion of objects due to gravity. Here we're going to look at some other forces, just common terms that we use when using forces. A force is really a push or a pull acting on an object. Force is a vector, which means that it has to include direction. And here's how we can signify that we're using force. Usually we use capital F with an arrow over top to indicate that it's a vector, and we'll use subscripts quite often to indicate what type of force we're dealing with. The standard units, or SI units, for force are newtons. And 1 newton is equivalent to 1 kilogram meter per second squared. Later on we'll talk about Newton's laws, and you'll hopefully understand more clearly why those units are equivalent. An applied force is just a general term for any contact force. So if someone's pushing a crate across a warehouse floor, you might say that they are exerting the applied force, or an applied force on the crate. So if there is no other specific term, we're not really sure what type of force it is, it's a general term we can use. Tension is another common type of force that we use every day. F sub t, or sometimes just t with an arrow over top. Of course, it's still a vector. Friction, very common, so F sub F or F sub Fr. There are different types of frictions. We'll talk about those later, and we can use other subscripts for those. Normal force, F sub n, and when we talk about friction, we'll need to know about normal force, so we'll talk about that in more detail later. Tension is really a pulling force, and is exerted typically by strings, ropes, cables. However, it could be exerted by other objects as well. It could be exerted by rods or ties or studs in buildings, rigid objects, so it doesn't have to be something like a string or a cable to exert a tension force. And the tension along a string or some other object is constant, so it wouldn't matter which part of the object I'm looking at. I could be looking at this part of the string or this part of the string. It doesn't matter which spot I choose. The tension is going to be the same throughout that string or rope. Friction, F sub F, is one way that we can write that. Friction opposes any motion or any attempted motion, and we'll talk mostly about sliding friction, and there are a couple of different types that we'll discuss later in more detail. Just briefly though, static friction is the force of friction that opposes the motion of a stationary object. So before it starts to move, the force of static friction opposes its motion, so F sub S. Kinetic friction, on the other hand, is the force of friction that opposes an object while it is moving. Both of these types of friction are associated with sliding motion. So these are to do with sliding motion. There's also rolling friction, which tends to be lower, much lower than these two. We're not really going to get into that in great detail. Air resistance is another type of friction. We can just write F sub air for that one. and we'll talk a little bit about that one, but we'll focus mostly, in terms of friction, we'll focus mainly on these two types. Quite often in physics problems we'll ignore air resistance just for simplicity's sake. However, engineers and scientists often have to consider air resistance because in the real world it can be a major factor on the motion of objects, particularly automobiles, as an example. The normal force is a force that acts between objects to keep them apart. So this is one of the contact forces. Objects have to be in contact with each other to exert a normal force on each other. Here's an example. If you're pushing on a wall, then the wall will exert a normal force on your hand that prevents your hand from moving through the wall. Some forces are action at a distance forces, so they don't require that objects are in contact for the forces to be exerted or to act. You probably recognize this action at a distance force, the one that keeps the moon orbiting the Earth. That's the force of gravity. And the gravitational force is a force of attraction between any two objects with mass. So you can choose any two objects in the universe and they will be exerting a gravitational force on each other. Gravitational force that the Earth exerts on an object is called its weight. That doesn't have to be the Earth. If you're on the moon, or an object is on the moon, then it would have a different weight. In that case, it would be the gravitational force that the moon is exerting on the object. And you can do that for any planet or moon or planetoid